All right, so let's start with number 70. So number 70 is the super gnarly one. I think it's the toughest one that we've done so far about throwing the shot put. So it says that the shot put is thrown 23 meters. There's a launch angle of 37 degrees, and the thrower pushes it for 2 meters on the way out. And we need the acceleration during the throw. So I'm going to start by sketching out the situation, just so I have like all my needs and givens. So here I am. I end up throwing the ball a total distance here of 23 meters. And by I mean somebody else, because I'm definitely not throwing the shot put that far. It comes out here at an angle of 37 degrees. And then I have the ball. Hey, Cole, we're doing AP Physics stuff for right now. If you want to hop back on in a little bit. And then I have the 2-meter push. So in this section, I have a change of X of 2 meter. This is also a change of X, right? That's my total distance of 23. And that's about all I know. So I need the acceleration. So I need the acceleration right here during the throw. So in order to do this, I'm going to start by saying, in order to find acceleration, and I have distance, I would use an equation that relates acceleration and distance. I also know that when I start throwing it from the very beginning, right there, my initial velocity, so v sub 0, is equal to 0 meters per second, because I'm not moving the ball until I start throwing it. So now I need acceleration. I've got a distance and I've got a velocity. So I could use the equation v squared equals v sub 0 squared plus 2a delta x. I need acceleration. I'm good with the change of x, that's 2 meters. I'm good with v sub 0, but now I need my velocity as well. Now I could go through and look at the other equations on the equation sheet, but they all require time as well as an x. And so I don't feel like there's really a better option than this one, right? Because I would need to know a time as well, and I don't know a time that I would be pushing that ball. And in order to find the time that I was pushing the ball, I would need the velocity again. So it comes back to needing that velocity in order to find the time. So I'm kind of between a rock and a hard place. So now I need to find velocity so I can use this equation. So my next piece is coming down. I could find the velocity because it's at an angle. I could create a little triangle here, and I could try to find my two components, v sub x and v sub y. So I'm going to try to figure out the two components of velocity in order to figure out the total velocity. And I don't really have enough information. I know that velocity in the x direction is equal to the change of distance in the x direction over the change of time. But again, I don't have a time, so I'm going to use time as like my little placeholder, because I do have the distance that it goes, right? The change of distance here is 23 meters. So that'd be 23 meters over time is equal to velocity in the x direction. So I'm going to kind of hold that as one piece of v sub x. I also know that I could figure out v sub x in another way. And to figure out v sub x in another way, I would say, okay, well, this part right here is just regular v, right? That's the total v. And I could say that v sub x is equal to regular v times the cosine of 37. So that one came from came from the right triangle sine cosine thing. So there's my theta. This one is v sub x. Nope, that's v sub y, sorry. This one is v sub x, and then this one is regular v. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So in this case, for v sub x is the adjacent, v is the hypotenuse. So cosine of theta equals v sub x over v. And then I could multiply both sides by v. That cancels, and I get v sub x equals v cosine theta. In this case, theta is 37 degrees, so I plug in 37 for that. So now I've got two representations of v sub x. I could set those two representations equal to each other and kind of get them combined. So I could say v cosine of 37 equals 23 over t. I took out the meters there just because the units are going to get in the way, and less letters will make it easier for me to follow. And then I want to set it equal to t because t is something that I don't have, right? I don't have a valid t, and I want to keep my v there because that's what I'm trying to solve for. So I need it in terms of v. So to get t by itself, I multiply both sides by t. That gets rid of that. And then I divide both sides by v cosine 37. So I get t equals 23 over v cosine 37. So what I'm trying to do here is I'm trying to solve for t in terms of v, so that then I can set t equal to another t. So let's take a look at the other t. The other part that I know is the v sub y part, right? So the v sub y part, I'm going to do these as like two separate even things. So the v sub y part, I could say, well, one way that I could find the vertical velocity is by doing acceleration times time. So I could say that the vertical velocity is equal to the acceleration in the vertical direction times the time. That's just a manipulation of the acceleration equation. Acceleration is equal to velocity over time, right? Change of velocity over change in time. And then I've solved it for v. So v sub y is equal to 9.8 meters per second squared times t. Then I could also say that v sub y is equal to, using my same trigonometric functions over here, the sine one was opposite over hypotenuse, and the opposite angle is v sub y. So it's going to be just the same as my x1, except I'm going to use sine and solve for v sub y. So over here, v sub y equals v sine of 37. Stop me if we're getting to a point where it's like this is a little bit iffy. Okay. Now I can set those two equal to each other. So I'm going to set this and this equal to each other to get rid of my v sub y's. And I'm going to get 9.8t equals v sine 37. And then to get t by itself, I'm going to divide both sides by 9.8. That crosses out those, and I'm left with t equals v sine 37 over 9.8. Okay, I'm getting closer. This takes a lot of kind of like pre-planning, but now I have two things that are both set in terms of t. So now I could say I can set these two components equal to each other. This time and this time are the same. The time horizontally and the time vertically have to be the same because it's in the air the same amount of time, whether I'm going up or sideways or both. So now I'm going to set those two equal to each other. That becomes 23 over v cosine 37 equals v sine 37 over 9.8. So my end goal here is trying to solve for v, and I've now got v as my only variable. So this is going great, right? I'm down to just v. I managed to eliminate the t there. Now if I cross multiply everything, I can say 23 times 9.8 equals v squared sine 37 cosine 37. All right, I'm cross multiplying my two pieces. There and there. Now I'm going to turn it into numbers. So sine of 37 is like 0.8 or 0.6. One of them is 0.8 and one of them is 0.6. So you multiply them together and you get around 0.48, I think. 6 times 8 is 48, yeah. So it should be around 0.48. 23 times 9.8 is 225.4 equals, this is around 0.48 v squared. Divide both sides, and I'm estimating there. Divide both sides by 0.48. 0.48 v squared equals 469. Then take the square root of both sides, and I get v equals 21.7 meters per second. So my velocity of the ball leaving my hand, or leaving this shot putter's hand when they throw it, is 21.7 meters per second. I'm just going to do a quick BS check and see if that could be possible. 21.7 meters per second, that's about 50 miles an hour. Could I throw a ball at 50 miles an hour? Yes, that seems reasonable. I mean, a baseball pitcher throws a baseball at like 90 miles an hour or 100 miles an hour. So a shot put is obviously bigger and heavier. It'll go slower, but 50 miles an hour seems in the realm of possibility. Okay, so now I have an answer for v. Now I'm going to take my v and I'm going to bring it all the way back up into there, to my original equation. So now I can come back to that original equation and I can plug in with my pushing information. So this delta x was 2 meters. My starting velocity was 0 meters per second. My finishing velocity was 21.7 meters per second. So I end up with 21.7 meters per second squared equals 0 squared plus 2 times a, that's what I want, times the change of x, which is 2 meters. The 0 goes away. 2 times 2 is 4, so I'm going to divide by 4 meters. Divide by 4 meters. 21.7 squared should be over 400. 400 and some 20 squared is 400, so this will be over 400 divided by 4. I should get an answer that's a little bit over 100. And I get an answer that is 117 meters per second squared equals a. So my acceleration during the throw is 117 meters per second squared. Now that's a pretty intense acceleration. That's like 12 times the acceleration due to gravity, 12 Gs. But it's also semi-reasonable. Like in sports, you can get really high accelerations on balls because you're kicking them or throwing them or hitting them. And so the ball changes direction really fast and you can get some big accelerations. Whew. So that one was double extra ugly, at least for me. It took a lot of kind of like pre-planning and pre-thinking out. So I had to really think about like, okay, what do I need? And then how could I possibly solve for elements of it? And in this case, I was solving for those elements of v sub x and v sub y, and then setting those equal to each other that allowed me to kind of treat them as separate and then combine them together with the time. Questions on that one? I think this is legit the hardest problem that we've done thus far. And it's harder than anything that I've found in chapter 4 or 5, so you can look forward to that. It's not as bad in chapter 4 and 5 so far. I haven't gotten all the way through chapter 5, but 4 was easy. You'll like that one. Yeah, this one, I wouldn't expect to see a question like this on the AP exam, to be perfectly honest. This is a super gnarly one. It's like I have it as a 5 or 6 step math problem plus trigonometry plus a bunch of stuff. Okay. Should we also go over, what was it, 45? Since we're here, let's take a look at 45. All right. So 45 asked, suppose D equals A minus B, where vector A has components A sub x equals 5, A sub y equals 2, and vector B has components B sub x. Okay, so I'm just going to write this out. D equals A minus B. Then I'm going to graph A and B because it gives me components for it. So I'm going to put it on a set of axes. And when I put it on a set of axes, zoop. All right, I have A, I'll do A in red, and B will be blue, and then D I'll make green. So for A, it is in the X direction, 5 over 5 up 2. So I go over 5 up 2, boom, there is A. It's 5, 2. B would go the opposite direction, -3 over here. That's -3, and then -5 down here. So it would go down to there like that, right? -3 in the X, 5 in the Y. And then it says, what are the X and Y components of vector D? Okay, so D is A minus B, but B is already negative, right? So if I wanted to make B minus that, because I have to do minus B, I would make those positive, positive. So now 5 plus over 3 more, 1, 2, 3, puts me at 8. And then 2 plus 5 more, 1, 2, 3, 4, 5, puts me at 7. So now this red one, or sorry, this black one is going to be negative B, right? That's over 3 up 5. So the first part are the X and Y components of D. So d sub x is equal to 8. I went over 8. D sub y is equal to positive 7. I go up 7. Then 45, draw a coordinate system and on it show vectors A, B, and D. Oh, good. I already did that. That is how I solved the problem. So by drawing the system, I've already done part B. This one's technically part B, and this one's technically part A. And then for part C, it asks me to draw, oh, C, what are the magnitude and direction of vector D? Okay, so my magnitude, oh, did I forget to do that part? I think I did. In my key, I neglected to do it. So let's do it now. The magnitude would be over 8 up 7. So d squared equals 8 squared plus 7 squared. D squared equals 64 plus 49. 64 plus 49, I need a calculator for, I mean, I don't, but 113. So D would be the square root of 113, which equals 10.6. So that's the magnitude. And then for the direction, that angle, theta, I have two values. I have 7 vertically and 8 horizontally. And I know that tangent of theta is equal to opposite over adjacent. So tangent of theta equals 7 over 8. So then if I do the second tangent of 7/8, tangent to the -1. So I'm doing tangent to the -1 of 7 over 8, like that, equals 41.2 degrees. So theta equals 41.2 degrees off the horizontal. Okay. And then another one that Gage noted was on 65. I'm just going to insert a picture of my key because I did it wrong. I mean, I did it right. I just did the math wrong. So I'm going to see if I can crop that for us just a little bit. Great. Okay. All right. So here is 65. And I made some mistakes on this one. One big mistake was right here. I had 2 times 9.8 times 6, and somehow I got myself an answer of 29.4, which is not multiplied correctly. So 2 times 9.8 times 6 should give me 12 times 9.8, 117.6. So instead of 29 here, it should be 117.6. Take the square root of that, and that gives me an answer not of 5.4, but of 10.8 meters per second. Then I take that 10.8 and plug it in for v sub y0, which is The time is still correct, but 10.8 goes in for here, right, instead of there. So that becomes 10.8 meters per second. 10.8 times 0.55 is twice as much. So instead of 3.0 meters, it should be 6.0 meters. So my apologies on that one. I made a math mistake, and that caused me to get the wrong answer. But the process was right. So if you came up with an answer of 6, you were correct. All right. Any others that you'd like me to go over? Any clarifying questions on any of those three?
I have a few that I need some help with still.
Yeah.
I looked over your work on these ones before I wanted to ask questions on them. I couldn't figure out how to do them still.
Okay. Which ones
One
are
of them
those?
was 15. I didn't understand it.
Okay. Do you have the rest of the list?
I just needed help on 15, 50, 55, and 75. I had a good bit of trouble with a lot of these.
Cool. 15, 50, 55, and 75. Okay. So let's do 15. If you guys are good and you want to drop off, feel free. Or if you want to stay on and go over these, then that's great too.
I gotta go. Thank
all
you.
right. Have a good one.
Yeah, you too.
So 15. And we are talking about problem 15, correct? Not question 15?
Yes.
Okay. So problem 15 was a wildlife researcher is tracking a flock of geese. The geese fly 4 kilometers due west. So I'm going to sketch it out. So they go that way, 4 kilometers. That's west. And then they turn to the north by 40 degrees. Okay, so I'm going to put in a 40-degree angle like that. Right? That is 40 degrees. And fly another 4 kilometers. Okay, so they're going to go out here, and that will also be 4 kilometers. How far west are they of their initial position? What's the magnitude of the displacement? Okay, so to figure out how far west they are, I need to take this 4 kilometers plus the x component of this second 4 kilometers, right? Because velocity x would be to the west. So I need to find v sub x of a 40-degree angle with a side of 4. And I can use that understanding that v sub x equals v cosine of theta. So v sub x equals 4 cosine 40. V sub x equals 3.06 kilometers plus my original 4 kilometers that they had gone west, giving me a grand total of 7.06 kilometers that they've traveled west. Then the other part is the total magnitude, or sorry, the total displacement. So that is how far they've gone sideways, right? 7.06 to the west. Now I need to find the north part, right? How far did they go total? Because I want to know what's their total displacement. How far did they totally go? And so I need that total length there. And in order to find that length, I need the 2 sides so that I can figure out the hypotenuse, because I want to do a squared, b squared, c squared. So to find the north part, v sub y, I lost me. There it is. Okay. So to find v sub y, that is going to be v sine of theta. So v sub y is equal to 4 sine 40. V sub y equals 2.57 kilometers. Now I'm going to do a squared plus b squared equals c squared. (7.06 squared plus 2.57 squared equals c squared. I'm going to take the square root of both sides, plug that into the calculator, and I get a total displacement c of 7.5 kilometers. Make sense?
Yeah, that makes sense. to
Cool.
me.
Yeah, I skipped some steps in the write out of that one.
It's okay. It's just a few of them I didn't understand. This is one of the ones that was a little bit confusing to me.
Yeah. How
And then
about
for ones like
50?
50, 55, 75, I just wasn't 100% sure what to do there.
Okay. Oh yeah. Okay. So all of these ones I think are really just about drawing the diagram. So it's like reading the description, and then once you get the diagram drawn, the rest of it kind of falls into place. So for me, for 50, a pilot in a small plane encounters shifting winds. He flies 26 kilometers northeast. Okay, so north is up, east is that way. So I'm going to go 26 kilometers up and to the right, because that's northeast. Then 45 kilometers due north. Okay, so then he's going to go 45 kilometers up. From this point, he flies an additional distance in an unknown direction, only to find himself at a small airstrip that his map shows to be 70 kilometers directly north of his starting point. Okay, so I end up here, right? And that's straight due north by 70 kilometers. And the question is, what's this missing piece? Right? So I know that I have to go back to the east. Oh, sorry, to the west, at least a little bit, because I came east a section here. And then I know that I also have this amount up here, right? So I've got that vertical part there. And that is a 45-degree angle because I went northeast. So I'm assuming it was a pure northeast, half north, half east, right? And half of the 90-degree angle is a 45. So that's a 45-degree angle. Oops, let's make that a little bit neater. 45 degrees. Okay. So the length and direction of the third leg of his trip. So to figure out how much is missing, I would have to say for the first section, I want to find, I'm going to call this A sub y and A sub x. So A sub y is equal to x, so A, full A, sine of 45. And in this case, the length is 26 kilometers. So I'm going to plug in 26 sine 45. A sub x is 26 cosine of 45. And both of those end up as the same distance as 18.4 kilometers. Good there? Okay. The b only has a y component, so that's b sub y. Right, I'm calling the second leg b, and then I'll call the third leg c. So the x component is just 18.4 kilometers. So for part C, I need to go back this way 18.4 kilometers. Then here, I've got 45 plus the 18.4. So when I add those together, I end up with 63.4 kilometers north. So this whole section up here was 63.4 kilometers. And I know that I have to get up to 70. So that leaves me with a missing section right here. 70 minus 63.4 leaves me with 6.6 kilometers. Now I do an a squared, b squared, c squared, right? 6.6 squared plus 18.4 squared equals c squared. Take a square root of that sucker, and I get a total length of c equals 19.5 kilometers. Then I got to figure out my direction, and I can do the direction by saying, okay, now I'm going to come back in and call that angle right there theta. That theta angle, I know it has an opposite side over here of 6.6, an adjacent side of 18.4. So now I can go tangent of theta equals opposite 6.6 over adjacent 18.4. Do a little tangent to the -1, right? So theta equals tangent -1 of 6.6 over 18.4. Theta equals 19.7 degrees. And that's 19.7 off the horizontal. So that's 19.7 degrees north of pure west.
Okay, makes sense. Yeah.
Yeah?
Mm-hmm.
All right. Should we try 55 as well?
Yeah, 55 and 55 was just confusing for me. The way you set it up looked simple. I just don't know why my brain got a little bit mixed up there. And for 75, I wasn't 100% sure how to go through that.
Okay, so 55, for me, it's like an easy logic problem. The textbook has it as one of its hardest problems. Those number of lines next to the problem indicates how hard they think it is. So they gave it a 4-liner, indicating that they think that's a pretty tough problem. For me, I said, if I'm walking myself, then I know that velocity is equal to distance over time, right? In any case. So I'm going to say velocity is equal to the change of x over time. The change of x is the same amount of distance, whether I'm on the moving sidewalk or whether I am walking with my own legs. It's the same distance. I don't know what the distance is, so I'm just going to call it x, right? It's a set distance that I have to walk from the, what is it, baggage claim to the gate in the airport or whatever it is. So if I am, so velocity of walking, right? When I walk by myself The time it takes me is 50 seconds. So velocity of walking would be x over 50. When I'm on the moving sidewalk, I could say velocity of sidewalk is equal to still the same distance over 75 seconds. So then my total velocity would be, if I'm walking on the sidewalk, I would get both my walking speed and the sidewalk's moving speed. So my velocity total would be the velocity of walking plus the velocity of the sidewalk, which is equal to x over 50 plus x over 75. Now it just becomes finding a common denominator thing. So the 75 one, I've got to multiply by 2. The 51, I got to multiply by 3 to get a common denominator of 150. So I end up with 3x plus 2x over 150, which is equal to 5x over 150, which is equal to x over 30, is equal to the velocity total. So remember that velocity is equal to distance over time. And now when I put them together, I have x, my regular distance, on top, and 30 sitting in place of my time. So the time should be 30 seconds.
Okay.
Okay. And then the last one is number 75. And number 75 says a Ford Mustang can accelerate from 0 to 60 miles an hour in a time of 5.6 seconds. A Mini isn't capable of such a rapid start, but it can corner really well. So it can turn a very small circle, 34 feet in diameter. How fast would you need to drive the Mini in this tight circle to match the magnitude of the Mustang's acceleration? Okay, so the big gnarly piece here is units. They didn't give us anything in meters per second. They gave it all in miles per hour and feet, which is kind of lousy. So I'm going to start by trying to find the acceleration of the Mustang. So I know that acceleration is the change of velocity over the change of time. And I know that the Mustang has a change of velocity of 0 to 60 miles an hour. So that's a change of 60 miles per hour over the amount of time that it took. And it said it can do that in 5.6 seconds. Now, the only problem is that seconds and hours are different units. So I'm going to convert my seconds into hours by using a unit converter. Here, seconds is the whole number, so it's on the top. So to get rid of it, I'm going to put seconds on the bottom, hours on the top. There are 3,600 seconds in an hour. That's 60 seconds in a minute times 60 minutes in an hour. 60 times 60 is 3,600. So it's 60 divided by 5.6 divided by 3,600, which gives me a total acceleration of 38,571 miles per hour, which is a really weird unit, right? So like 38, you'd be like, oh my God, 38,000, but that's miles per hour, which isn't really a way that we think about acceleration. So that's fine. And I'm only holding it there because I'm eventually going to want my acceleration of the Mini in miles per hour. So for the Mini, it's going in a circle. and I have an equation for acceleration in a circle. It's the centripetal acceleration equation, and it's in your physics everything, or sorry, the AP cheat sheet. So in the AP cheat sheet, it is the 6th one down. Acceleration centripetal, A sub C. So the equation for that one, for the mini, is going to be A sub C is equal to V squared over R. So my R will be 34 feet is a diameter. So half the diameter is the radius. 17 feet is the radius. And I'm trying to solve for the velocity because I know the acceleration that I have to match. So I would do 38571 miles per hour squared equals V squared over 17 feet. But 17 feet is not the same as a mile. So now I have to do a unit conversion to go from feet to miles. Jerk. Feet on the bottom, miles on the top, and then you got to look it up. There's 5,280 feet in a mile. This is why we like the metric system, because it doesn't use converters like 5,280. So I would do 17 divided by 5,280. Multiply that by 3,857, or sorry, 38,571. That gives me 124.2 miles per hour squared equals V squared. Take a square root of that whole sucker. The velocity of the car has to be 11 miles per hour.
Okay. Yeah, that makes sense.
Cool. All
Thank
right.
you so much.
So I
I
think,
just got to finish up one of these problems, and then I can turn it in.
nice.